All right. Still, again, we're a little bit early. Let me link the stream into the chat. And we are good to go. Just waiting a few minutes on people to join. I'm so happy to be done for the weekend. That's going to be nice. Leave this room for, several hours at a time. Yeah, I'm just gonna wait it up. Just waiting. We're having pizza tonight. Excited about that. Our pizza choices. Pizza Hut. Oh, we have a viewer. I'll stop looking at pizza. Alright. This quiz will probably stay up for a while after the lesson. I'm going to put up the review tonight at some point, but I will be leaving the house almost immediately after, so it might be a little bit before I put the review up. What is this? Oh, it's a 3D printed part. It looks like it's trash. All right. It is 5 o'clock. Wait till 5:01. It'll get started. All right. I'm just gonna wait. Okay, it's 5:01. Let's do. Oh, that's gonna need to be bigger. All right, this should put this up long enough that if somebody's scrolling through on a other video, or if I edit this later, I should be able to see. Oh, starting now. Good. All right, in North America, power is generated at a frequency of 60 of 60 hertz. Electrical distribution system shutoff devices operate in a similar way to overcurrent devices. My robot vacuum is just, it's acting like it wants something from me. It's just sitting at the bottom of my chair, just hitting the chair. Alright. Yes. So the shutoff devices and electrical distribution system operate like breakers and normal overcurrent devices. The most efficient way to send electric power over transmission lines is at the lowest current possible. That is because let's see. Yeah, that's good. So, just like our figures for current earlier, if you were trying to send 1,000 watts to a load, so we're gonna do 1,000 watts. You could send 100 volts at 10 amps, or you could send 10,000 volts at 0.1 amps. These are, I mean, you could send a bunch of different voltages and amperages, but I'm giving you two options. I'm narrowing it down. So at the 100 volts at 10 amps, you're going to have either one of these, you're going to have the same wattage, but let's see, P, we're going to be using P equals I squared R for our formula. So that's 10 squared. And we'll say we have 2 ohms of resistance in both of these. So we're saying the resistance of the wire going out to this thing is 2 ohms. We don't need to care about the voltage on the wire, like the voltage drop. We're going to say that we're doing whatever it takes to get the 100 volts to the obstacle, or to the load. So 10 squared times 2, that's amps and ohms. That will give us 10 squared is 100 times 2. So that would be 200 watts lost in the wire. So we're going to have to produce 1,200 watts of power to get 1,000 watts of power at the load. Conversely, this is 0.1 squared times 2. Well, 0.1 squared, I believe, is 0.01. Point 0.1 squared. 0.01. Okay, I'm not wrong. So, and then times 2, that would be 0.02. So in this situation, we would have to produce 1,000.02 watts to get 1,000 watts at our load. So clearly, the lower you can bring your amperage, the better. So what we do with a transformer is we bring the voltage up incredibly high so that the amperage is really low, and then whenever it gets to its where it's going, we just bring the voltage back down in the transformer to a usable voltage. Okay, where's my, there it is. When power lines are operating at their maximum power load, they can get hot and can sag and reduce clearances to vegetation. That actually has happened a number of times whenever they were first doing power lines. They didn't really have, they were like, and they didn't really have good backup systems, and a bunch of lines got too hot and shorted out and broke and stuff. And that was bad. Now they do a lot of things. They have much higher voltages, so the power lines are dropping less wattage. And also, they have trucks that drive around and clear trees up. Oh, wait, no. That's not the next button. A blank is a machine that converts. This is a generator. Uh, Mechanical energy to electrical energy, that's a generator. We have covered that thoroughly. And then finally, utilities normally generate three-phase AC power. That's because it's easier to generate it at three-phase and then convert it to single-phase than it is to generate it at single-phase and convert it to three-phase. Even though there's fewer people using three-phase power, usually those are some of your larger loads, and it's just easier to go three-phase and then split phases off to bring to your single-phase loads. All right. That's not, oh, I didn't mean to end that. I'm going to put this back up. Same quiz. So if you've already done it, don't bother. It's going to be up for a bit. I just want to give that handful of people that didn't do the first one a chance to do it. Do it the first time, a chance to do it. All right, you guys have a good weekend. I'm going to, and I will see you guys in a couple weeks. Get your tests done and bring it back to the school on your next class day. All right, thank y'all so much. Y'all have a good weekend.